that's another thing, is differentiation that has to do with this. Y is equal to 4x cubed dot sine x. We've been asked to differentiate this. And still remember, it's product rule method. So our solution is going to be explaining the concept of a product rule once again. Alright? So what do we do? First of all, let's begin at this point. We have y is equal to 4x cubed dot sine x. Understand this. I'm going to solve from this angle to that point. So let's understand this. What this simply means is that we are going to apply product rule. That's the meaning of dot. Dot means times. In other words, products. 4x cubed product x sine x, right? 4x cubed product sine x according to this. Alright? So with that concept, we now have that u is equal to 4x cubed. And then our v is equal to sine x. The equation that we're going to define as product rule is y is equal to uv. We have redefined this. So this is equivalent to what we have here. Because by the time we substitute the value of u as 4s cubed, we have it here. And then substitute the value of v as sine x, we have it here. We go back to what we have already. So with this, we'll move on. What do we do? First of all, we are going to differentiate u with respect to x. So our u is 4x cubed. Differentiation goes this way. 3 times 4x, 3 minus 1. And finally, we are going to have 12x cubed. That's for du dx. Differentiating u with respect to x will give us this. Take it. 3 times 4 is 12, and this will reduce to x cubed. That's x squared, I mean. Then the next one is dv with respect to x, meaning we are going to differentiate sine x v with respect to sine x. That is x in the sine. So what do we have here? When we differentiate sine x, we have cos x. Alright? That is it. It's very simple. We don't need to go further here. Therefore, since we have done this, now we need to find dy with respect to dx. How do we get this? By keeping u, that's the concept. We keep u, okay? We keep u, differentiate v with respect to x. Then we put our plus sign. Alright? Then we go again, keep v, we have to keep v this time around. We keep v, alright? And then differentiate u with respect to x. So this is the formula known as product rule. Isn't that interesting? Very, very interesting. The next thing we are going to do is to substitute. Where we have u, we substitute 4x cubed. Where we have dv dx, we substitute cos x. Where we have v, we substitute sine x. And then where we have du, okay, dx, we substitute 12x squared. And that's all. So let's go. The other side. Let me take chalk. Okay, so we do that right away. We continue with dy dx is equal to, watch this. Look at this. U, where is our u? Look at it. 4x cubed. Then where is our dv dx? cos x. Cos x. Good. So we move on again. We have plus, what do we have as v? V is given as sine x, and that is sine x. What do we have as du with respect to the x? Du dx. Where is du dx? Look at du dx. We have 12x squared dot 12x squared. That is it. Look at it. Very simple. Let me take one more chalk. More chalk. Okay. So, look at it very well. We can now go forward and have the x is equal to, we have 4 is here, right? We have that. We can still rearrange this. 4x cubed cos x plus, look at this. We can bring this here. It becomes 12x squared sine x. Very simple. All right? So we move on again. Another thing we need to do is dy over dx is equal to, of course, we find that 4 can divide 12. So if we bring out 4 and x, how much x will come out? Look at it. It's cubed here. So what do? It becomes x squared, brackets, x is going to be in, and we have cos x plus, so let's see what happens here. What number will be multiplied by 4 and we fall back to 12? So that should be 3. That should be 3. So we have 3 sine x bracket close. This solves it. That's it. Very simple. That's our final answer. So with this, we have finally succeeded in finding the differentiation using product rule of this function, of this equation, y equal to 4x cubed dot sine x. That is it. Come on, let me thank you for watching up to this moment, for your patience. My returning subscribers, my new subscribers, thank you so much. Before I let you go, as usual, please subscribe if you have not subscribed. Give me some thumbs up to encourage me, okay? And then put on the bell button for constant notification so that each time content of this kind is uploaded, you'll be notified. Don't forget, share with your friends, networks, and students. I am signing out to prepare for another class. Thank you.